Okay, let's continue. You are given question, you are now in question number 17. It says solve e the power of x sine y plus 3x squared dx plus e the power of x cos y dy is equal to 0. So let's see how we can solve such kind of d. Basically, this is an exact differential equation because I'm now going to show you how you can solve exact differential equation. So the solution goes like this. So dear students, consider this is a 1 which is written as a coefficient of dx as m. So e the power of x sine y plus 3x squared is considered as your m value, and your n value will be, or your n expression will be, the coefficient of dy, which actually is e the power of x times cosine y. So let's now first assure whether whether the partial derivative of m with respect to y is the same as the partial derivative of n with respect to x before we conclude that this is an exact differential equation. Okay, so the partial derivative of m with respect to y here comes to be e the power of x cos y. The reason is, you see, is the derivative of sine y is cos y, so e the power of x is taken as it is. Here the partial derivative of n with respect to x is e the power of x itself times cos y. So as can be shown here, my and nx are basically the same, so my is the same as nx, hence the given differential equation is exact. Basically, dear students, this differential equation is the one we did before. So this is an exact differential equation. So now how can we find the solution of what? This kind of differential equation. The solution of a differential equation, as I told you before, is nothing but it is an equation which is free from derivative and can satisfy the given differential equation. So let's see how we can solve that. Basically, there are different methods, basically two methods in order to solve exact differential equations. One is using grouping technique, and the second one is using the derived formula. So as I told you in our class, I recommend you to apply the derived formula because it is applicable for any sort of, you see, exact differential equation. So let's do this again by using that approach. Now this is going to be the formula we are having. Remember, students, we were having two different formulas, but one can use this one directly, and if you are not interested by this, you can also use the other one, you see, and the other can easily be obtained simply interchanging m by n, x, and here x by y. Okay, x and y, you need to interchange both of them. Okay, so we can simply obtain the other one simply by interchanging m by n, x by y, and doing so we can directly obtain the second formula. Okay, so this is the way you need to have these two formulas just to remember. Now we are having this integral of m dx plus integral of n minus partial derivative with respect to y of integral of m dx dy equals c. So we knew what m and n are. Here they are. M is here and n is here. So let's carry out the integral of this one with respect to dx, because it says integral of m dx. Mind you, student, this integral of m dx is again repeated here. You see, integral of m dx. But here we need to what? Take partial derivative of the one we obtained here with respect to y. So let's perform now these two one by one. So let's find first the integral of m dx. So find the integral of this expression. So the integral of m dx is going to be this one. Look, we knew what m is. We directly copy this and paste it here. E the power of x sine y plus 3x squared. So as you are integrating this with respect to x, e the power of x sine y is treated as a constant one because the integration is performed with respect to x. So take sine y as a common out, and the integral of e the power of x is e the power of x, right? E the power of x sine y, because sine y is a constant, is taken out. And the integral of 3x squared dx makes x cubed over 3, so 3 cancels 3, then x cubed can come. So as you see, e the power of x times sine y plus x cubed is going to come. So this is the integral of m dx, students. This is the integral of m dx. So now we are expected to carry out the partial derivative of the one we obtained here, because the partial derivative with respect to y of the one we obtained here is required in this case. So what we need to do is, you see, partial derivative of the one we obtained with respect to y, that is to say the partial derivative of this one with respect to y. So as we are performing this, the derivative of sine y makes cos y, So this is turns to be e to the power of x cos y, as you see. And here we don't have y, so the partial derivative of this respect to y goes 0. So e to the power of x times cos y can come, as can be shown. So now what's coming next is the following one. Look, using the star given above, it's a matter of direct substitution. Students, just try to substitute this one where here, because it's already obtained, and again is a power of x cos y is the result for this one, and we knew what n is, so applying this formula and applying integration, we can directly come to the final solution as follows. So this is the integral of, as can be shown, this is the integral of m dx plus the m dx, and here we have the integration as you see. Now we need to take n. Where is n? And here is the power of x times cos y. So you will have e to the power of x times cos y minus. Now what has been obtained here is the partial derivative with respect to y of this one. It is already done. It is e to the power of x cos y, as you see. It is directly used. Then dy is equal to c. Dear students, nothing is written here. I just applied the derived formula, the one we derived in our classroom, okay? This formula directly for my calculation. Now, dear students, what is obtained here is e to the power of x cos y minus e to the power of cos y. This will be 0. And from this you can understand that the integral of 0 dy is a constant number, because it is a derivative of a constant that makes 0. Remember, integration is a reverse process of derivation. So if you do have 0 inside a certain integral, then expect that the result is a certain constant, because the derivative of the constant one is 0. So from this you can understand that e to the power of x sine y plus x cubed plus, now for this result we have taken a certain constant c1, because this one is 0. You see, 0. The derivative of this one is 0. Then what follows is c. So we can consider, look, this as a solution, but instead of having two constants appearing here, let you take c1 to the right, and then e to the power of x sine y plus x cubed equals a certain constant can come. So this is going to be the solution for this one. So from this, what you need to understand is whenever you are sure that the given differential equation is exact, you can directly apply this formula and find the solution as you see. Next from this we have, you see the next question, and that is solve e to the power of x sine y plus 3x squared dx plus e to the power of x cos y dy equals 0. So again here students, let's assure first that this is what? Exact. Now your m is going to be is the coefficient of dx, which is e to the power of x sine y plus 3x squared, and your n is going to be e to the power of x cos y. Now let's apply direct integration both sides. So the partial, let's apply partial derivative with respect to y and with respect to x for each of these two one by one. So the partial derivative of m with respect to y is going to be e to the power of x times cos y. Since we don't have y here, it will be 0. And the partial derivative of n with respect to x is going to be e to the power of x times cos y. Now my the same as nx, so this is an exact differential equation. So look, I'm now using another formula, students. What I'm doing is I'm just solving the same question by using two different formulas, okay? So previously I was using another formula, but now this is the other one. Now what is the difference between the two is? The difference between the two is sensed in the following way. Look, in the first case, we were having m here, m of xy dx plus the integral of, this was n minus the partial derivative with respect to y of the integral of mxy dx dy. It was like that. But now look, what has been changed here is m is completely changed to n, and y and x are completely interchanged. So if you just memorize the first one, you can simply interchange m by n and m by n and x by y in order to know the second formula, which is actually this one. So now the integral of n dy plus the integral of m minus partial derivative with respect to x integral of n dy times dx equals c is written. So let's see how we can solve this one by using this approach. So as we did before, first we have to find the integral of n dy. See, the integral of n dy, and is already here. So let's integrate this one with respect to dy. So as you are performing that, the integral of e is a power of x cos y dy comes, and since we are integrating with respect to y, e is a power of x is taken as a constant out, and then integral of cos y comes sine y, as can be shown. So we now determined integral of n dx. So this is already determined, but we need this result where over here, because we need to perform partial derivative with respect to x of the result we obtained here. So we need to find the partial derivative of this expression with respect to x, because that is required here. So the partial derivative with respect to x of the integral of nx dy dx is the same as the partial derivative with respect to x of the one we obtained here. And as you are performing partial derivative with respect to x, is a power of x comes as it is, then sine y follows. Now everything is obtained. Then the next task is a matter of plugging appropriate expressions in their place. So using the equation star above, one can obtain this one. Look, students, I simply substituted the result of the integral of nxy dy. Here it is. This is already obtained, is a power of x sine y. I just took that as it is, plus the integral comes as it is. Then we knew what m is. Where is that? Here it is. Simply copy this and paste it here. It is taken here, as you see, minus. Now the partial derivative with respect to x of this expression is already done. Here it is. It's obtained to be is a power of x sine y, as can be shown. Then dx comes equal c follows. This is all about this expression. Now we need to perform this integration, students, and in order to perform this integration, look, what is going to come here is, look, e is a power of x sine y can be cancelled by e is a power of x sine y. Then what is remaining here is e is a power of x sine y plus, now look, these two can be cancelled, then integral of 3x squared is going to come, and we knew that the integral of 3x squared is x cubed, right? X cubed, then equals c comes. Look, students, the one we did before is identical to what? This one, because we can apply, you see, one of these two once if we are sure that the given differential equation is exact. And which of these two do you think is better? I hope the second one is better. So it's up to you to choose the better one whenever you apply, you see, these two formulas in order to solve exact differential equations. I hope you have understood.